Hello everyone. So in last class we have discussed regarding insulation techniques, right? So what all the methods of insulations are there? Thermal insulation, okay? Then their applications we have discussed in detail, their functions we have discussed in detail, okay? So in continuation with that, in today's class we are going to concentrate on thermal insulating materials, right? So the first bit is thermal insulating materials. So in this case we are going to concentrate on what are the materials we are using for this thermal insulation technique, okay? So before going to start with the materials, because materials are predefined, okay? So they are available in market, okay? So depends upon the requirement, we can purchase them and we can install them, or in some cases even we can combine one or more number of materials available in market, and we need to add some adhesives for that, or we need to add some admixtures so that we can prepare a well mix, okay? By using different techniques of insulations, we can use those things to roofs or walls or ceilings, or even in some cases outside the building, okay, inside the building, depends upon the requirement, we can use insulating materials. So before going to start with the materials characteristics, first we need to understand the use of thermal insulations, okay? So the first thing we need to concentrate as use of thermal insulation, okay? So if the air outside the area is cold, you may want to protect your skin by wearing clothes that keeps the cold out and the body warm inside. That's all. So this is the simple funda behind the using of or usage of thermal insulations. Even in most of the cases, yes sir, we prefer, usually in winter season, we prefer a thick cloth so that it will in turn transfer the minimum cold inside the sheet, okay, sheathing material, okay. Even in the same cases, if in summer, of course we prefer little bit thin cloths so that we can feel comfortable. So that is nothing but the insulation techniques which is incorporated in our day-to-day activities, okay. Similarly, if the house has cool air inside during the summer, you may want to prevent the temperature from becoming the same as the hot air outside by having the house well insulated, okay. So this is nothing but the simple funda behind the use of insulatants or thermal insulations, okay. So in continuation with that, how does insulation work, okay? So on what principle it works, or what are the basic behind this insulation technique works, okay. So as we know, insulation is a barrier that minimize the transfer of heat energy from one material to another by reducing the conduction, convection and radiation effects, okay. This is nothing but simple thermal insulation techniques, of course. So it will in turn most insulations issued to prevent the conduction of heat, because radiation, of course, because it's through air, because air is in turn minute in nature, okay. So we should not supposed to say 100% we can eliminate it, but in solids as well as in liquids we can at least expect a better efficiency, okay. Similarly, the less dense materials are the better insulators, okay. So we should always prefer, that's why always see, for example, in false ceiling, okay, or in sunken slab portions, okay, especially we are preferring some lightweight materials. For example, your thermocol sheets, of course, it's a very good thermal insulating materials. So they are of lightweight, okay. So less dense material will always be a very good insulators, because if the material itself is heavy, automatically the lifespan of that particular material is going to be minimum, yes or, because of its self weight, it will drag or deflection takes place. For the small application of load, there is a chances of getting failure takes place, okay. Then the gas insulators are better than liquid insulators, okay, right. So the next point is insulation from conduction, right. So as we already know, conduction is the process of transfer of heat through the solid bodies, okay. So by adopting these insulating materials within the materials or within the construction or within the manufacturing of that particular product, so that we can in turn minimize the conduction. For example, nowadays we have what you can say dust based product or the byproducts based products. For example, fly ash, of course, it's a byproduct, right? Then rice husk ash, it's a byproduct. So, we are using these byproducts for the preparation of other main product or material which is used for construction activities. So, that is why the insulations from conduction is will always is going to reduce. Okay. I mean, of course, the conduction process will in turn reduce by adopting these insulations even at the time of manufacturing of that particular product. Okay. For example, compressed wood, of course, they are used by taking a sawdust, okay, with some adhesives or some admixtures, okay, and will have that compaction on both the sides, so that it will form in a sheet. Yes or no? So, that will incorporated with some other reagents or some other agencies, so that we can make it as very good insulating material, so that it will in turn reduce the conduction, that is thermal conduction, that is the heat transfer through solids. Similarly, insulations from radiations, right? Even radiation effect also we can minimize by adopting these insulation techniques or insulating materials at the time of constructing those products or the component of the buildings or materials. So, radiation is a transfer of heat from warm objects by radiating infrared electromagnetic waves, which can be prevented by a shiny material to prevent radiation heat transfers. Yes, nowadays we have observed that, especially in aluminum composites panels, ACP sheets, okay, on the edge they are going to have a thin shiny sheet. Of course, that is made up of some polymer based products or some carbon nanoparticle based products. Okay. So, they are going to affix on the extreme end, so that it will even give very good appearance to the building, and as well as it will in turn minimize the radiation effect. Yes or no? So, that is the advantage and or the use of the insulating materials. Okay. Then the next bit is R value. So, what is this R value? Usually we can call this R as a resistance value. R value simply, or we can call it as resistance value. What is this resistance? Okay. So, resistance, usually we know that resistance is nothing but it is something in opposite direction. Okay. If one vehicle is coming or any object is coming in opposite direction, if you resist them, if you are having a force in opposite direction or the resistance in opposite direction. Similarly, this R value is nothing but even in insulation technique also we will prefer this R value, that is resistance concept. So, the R value of material is its resistance to heat flow and is an indication of its ability to insulate. Yes. So, and at the same time this R value, that is resistance value, may vary from materials to materials. Okay. You may not expect the same R value for all the building materials. Yes or no? Because it is used as a standard way of telling how good the material will insulate the heat, and the higher R value, the better will be the insulations, right. So, how we are going to calculate this R value, right. So, R value is always going to calculate as square meter, that is area square meter multiplied by degree centigrade divided by watts in metric system. Okay. Even in the same cases, if in English system will prefer square feet of that area multiplied by hour into degree Fahrenheit divided by BTU, that is British thermal unit in English systems. But usually we will prefer calculation of R value in this manner, that is square meter. Square meter is nothing but your area. Okay. Area of that particular building or room or component in square meter multiplied by the degree. Degree is nothing but difference in temperature. Okay. For example, if you are planning for 30 degree will be the optimum temperature, okay, then 20 degree will be the minimum temperature, we can say. So, maximum is 30, minimum is 20. Within that we need to check it out which material is suitable for insulation, okay, or which material I need to prefer for that particular range, because the range of temperature we have already discussed in previous class. Yes or no? So, that is basically we have classified that thermal resistance concepts into 4 different temperature grades, or the 4 temperature systems. One is low temperature, okay, ambient temperature, moderate or medium temperature, and a high temperature. Yes or no? So, depends upon the temperature range, the R value will going to differ, right. If in a high temperature region, if the difference in temperature itself may be around 70 degree to 50 degree, let us say 70 degree centigrade to 50 degree centigrade, or 70 to 30, depends. Okay. So, the difference of the temperature we need to take into consideration, that is nothing but a degree, that is difference in temperature multiplied by the square meter area divided by watts. Yes, that watts is nothing but the resistance value, that is per square meter what should be the resistivity available for that particular material. Okay. So, on that basis we are going to calculate the R value for the insulating materials. Okay. So, in this tabular column, right. So, in this tabular column we can observe the different materials having their different R value, right. For example, a hard wood of 1 inch thick, the value is 0.91. Similarly, for wood it is 0.87, brick is of 4 inch thick is 4. Yes or no? So, we can observe there are n number of materials are available in market. So, depends upon the requirement, depends upon the type of building, depends upon the budget available, we can decide which material we need to prefer. Okay. This is regarding R value, right. So, in continuation with that, the next bit is, if we are adopting this technique, that is insulation technique in slabs or walls or outside the building, that is for the exterior walls or for interior walls or for ceilings or for flooring at some extent. So, how the applications are going to vary. Okay. That part we are going to discuss now, right. So, the second bit is slab or block insulation. Slab or block insulation. Okay. So, the term slab or block insulation is nothing but, of course, we can observe in this figure, right. So, the sizes of the blocks or a slab type of area is available in 2.5 centimeter thick, that is 1 inch thick, and the area is 60 centimeter by 120 centimeter, okay, or even more in areas. Okay. Even we can have we need to join those panels, okay, one over the other, depends upon the requirement, depends upon the area to be insulated. Okay. So, especially these types of insulation techniques is preferably good in RCC slabs. Okay. So, you can observe in this figure, these may be made of cork board or mineral wool or cellular glass or cellular rubber, sawdust, asbestos cement, etc. And these are fixed to walls, slabs as well as for roofs. So, in this figure we can observe, okay. So, the first figure represents the insulation for slabs, right. So, we can observe at the end we have a support for the wall thickness, it might be of wall or it might be of beam. Okay. Then the entire slab is in turn going to rest on the supports, it might be wall or beam. Okay. So, you can observe that white portion is nothing but the insulators, right. They are available in different area sizes. Okay. Thickness may vary from 1 inch, 2 inch, 3 inch, 4 inch, depends upon the requirement. Okay. But then area, once again minimum area is 60 by 120. Okay. So, that is 0.6 meter by 1.2 meter. If we want more than that, so we need to join them together by using some suitable adhesives. Okay. So, on above we need to place or we need to pour concrete, okay, that to a lightweight concrete, not the heavy weight I can say, because they are not going to take that much of load. Usually these types of insulating materials used for slabs are of light in weight, and we should not supposed to have load on that particular slab. Yes, they are just acting as the non load bearing structures. Okay. They are just minimize the heat transfers from the on your top portion of the building or warehouse or industrial buildings, whatever might be the case. Okay. Below we can have these types of arrangements, so that, or even at ground floor level, ground floor slab, we can prefer these things. Okay. Then on above, the entire thing is open to sheet type of roofing, or GI sheet or AC sheet roofing, something like that. Below that we can use these kinds of insulating materials. Okay. So in this case we can even observe how the insulating materials are going to work, right. So the second figure shows a solid ground floor insulation over the slabs, right. In this figure we can observe the bottommost part is of inner wall, right. On above we can have a hard core, right. It might be your normal concrete, okay, of minimum thickness. On above we can have a sand bed, right. On above we can have DPC, that is damp proof cores or damp proof membrane, because it should not absorb the water and it should not in turn percolate the water inside the building. Okay. So we have a damp proof. On above we can have a concrete slab, right, of so and so thickness, it may be 4 inch, 6 inch, depends, right. On above we can have insulation. We can observe that white strip, okay, in both isometric view as well as in cross section, we can observe that insulation material. Okay. So on above also we can have a vapor control layer, that is VCL. So vapor control layer. On above we need to go ahead with a screeding, that is screed concrete, okay, because once the rainfall, even though if that surface is exposed to atmosphere, okay, so of course at the time of rainfall takes place, so the rainwater should not supposed to absorb. Okay. That is why we need to provide on top screeding, right. So this figure shows the details about how the insulations are done for slabs, right. Similarly for walls, okay. Similarly for walls also the concept remains the same. Okay. So on walls we can have on the either side or any one particular side. Okay. Depends upon the requirement. We can go ahead with insulations for slabs as well as for walls. So the second one is, okay, in that the first one is slabs, then the next one is blanket insulation. Blanket insulations. Of course, the name itself is quite simple, right. In this case, blanket insulations are nothing but, right. Yes, we can observe in this figure, right. This figure shows the typical blanket insulations, right. So these are flexible fibrous rolls made from mineral wool, processed wood fibers, cotton, animal hairs, etc., available in a thickness of varied depends upon the requirement, right. So the thickness may vary from 12 mm to 80 mm. So these are directly spread on the wall or ceiling surfaces, right. We can observe in this case, so the thickness may also vary, okay. It depends upon the requirement, depends upon the budget, so we can vary the thickness of these blankets, okay. Then the third one is loose fill insulation, or the next one is loose fill insulations. Loose fill insulation, right. So in all the cases, in majority of the cases, we may or may not get area in terms of spreading, okay, or we can get in terms of square meter or something like that, square feet, okay, length into width. It may not possible in some cases, because we need to prefer these insulating technique for the small portion or any one particular portion of the building, okay. So in these situations, even the availability of these insulating materials in the form of pellets, okay. So in this figure we can observe the loose fill insulations, right. So they are nothing but flakes types of structures, okay. So may consist of fibrous materials like rock wool, slag wool, cellulose or wood fiber wools, etc., filled loosely in the studding spaces, right. So we can even mix these types of pellets with some other admixtures, so that it will give you a better insulating technique. The next one is bat insulations, right. So, they are similar to blanket insulation, except that these are small in size, but of greater thickness. You can observe in this figure. So, how the bat insulation technique, right, we can observe, especially this photographs indicates the insulation process below the slab, that is at ceiling portion. Okay. So, there are some vertical rafters are there, right. So, no cross rafters, okay. Only the main rafters are running, okay. On above we can have a slab, it might be of wood or it might be of screed concreting or it may be of lightweight concrete, okay. So, below that there is a huge bed of insulation, right, which is done with a uniform thickness and by giving a uniform interval, okay. You can observe the interval between those rafters are of similar, okay. So, the rafters are running in this throughout the entire length. In between we are going to fill up the insulating materials, okay. This is regarding bat insulation technique, okay. So, the next one is insulating board. Insulating board. Insulating board, right. So, in this figure we can observe, so it is exactly nothing but your compressed wood, yes, or it might be of some plywoods, I can say, okay. So, that is the insulating boards. So, we have exterior sheet or sheeting portion as well as interior sheet, right. So, in between these two exterior as well as interior sheet there is a foam core which is available, okay. So, by using proper adhesives, right. So, there is a material which will in turn fit between the interior and exterior sheeting portions, okay, with varied thickness. Thickness may vary from 1 inch, 2 inch, 3 inch, so on, okay. So, we can use these types of insulating boards in partition walls, in some ceiling portions, even in some roofing areas also we can prefer these types of insulating boards, okay. Then the next one is lightweight aggregate, okay. So, the next, of course, this is also one of the very good insulating material, right. Lightweight aggregate. Lightweight aggregate, because in majority of the cases which are not supposed to go ahead with dense materials, okay, or a huge dimensions or the materials of greater density, okay. So, always we need to prefer the lighter one, because as the structure goes vertically upward, okay, especially in high rise building or skyscrapers or multi-story buildings, okay. So, G plus 10, G plus 12, yes or no. So, as the building rise in vertically upward, so automatically the uppermost part of the buildings we need to make it light in weight by adopting the lightweight concept, right. Even at the time of preparing aggregate for that particular concreting portions, we can use lightweight aggregate. It might be of natural available lightweight that is pumice, or we can even use some artificial lightweight aggregates, okay, by adding some other mineral admixtures to together with cementitious materials, so that we can prepare lightweight aggregate. That is also very good, one of the very good insulating technique, okay. So, heat resistance of concrete can be greatly increased by using blast furnace slag, then burnt clay and vermiculite, okay. Then the next one is reflective sheets. The 8th point is reflective sheet, right. So, reflective sheet. So, in reflective sheet has very high reflectivity and low emissivity, thus offering high heat resistance. So, it consists of gypsum boards, then steel sheets, aluminum foil, etc., right. We can use these materials in as a reflective sheets, okay. If you prefer a shiny materials on the exterior portion, okay, automatically the heat transferring from outside to inside is minimum. Okay. Then the 9th point is air barrier. Air barriers, right. So, we can observe in this figure, the air barriers are effectively retard or stop the flow of warm moisture laden air from inside a building outward through walls, ceilings and floors. Okay. So, you can observe in this figure, so there is a external wall, okay, exterior surface, and there is an interior surface. In between we have insulating material. Yes. So, at one place, at one particular thing, if you provide a vapor barrier, then automatically the moisture transfer from one end to other end is going to be minimized, is going to be nullified. If you are not provided that vapor barriers, no vapor barriers or no air barriers, then automatically the heat will in turn transfer from inside to outside or outside to inside with a minimum amount of transfer. Okay. If we have a 40° centigrade outside, not exactly 40° centigrade we can expect inside, but with a reducer manner, it reaches to 32°, 34°, 35°, depends upon the type of building, type of materials available, then type of insulation technique adopted, right, depends upon the type of region. Okay. But if you provide a vapor barriers in between, so automatically they will in turn minimize the transfer of heat as well as cold as well as moisture from inside to outside or outside to inside. Okay. So, these are the different thermal insulating materials available in market and adopted in construction activities. Thank you.